Hello everyone, welcome back to our third event on Python for scientific applications. In the first class we covered how to install and how to configure the unaccountable distribution. In the second class I have shown some basics, some fundamentals of the language, and today I will start with dealing with files and data aimed at statistic analysis. So if you're here at Jupyter Notebook, the first two packets that we're going to use more when dealing with statistics is Numpy and Pandas. They both have usual nicknames as NP and PD, and they have very different approach. Numpy, as I told you, is a package for matrices and linear algebra manipulations, and Pandas is a package that deals with tables, in the sense that a table is a matrix with names, with labels. So that's very common so to deal with databases and also scientific data with particular properties. They are named. And we're going to use this as a tool to read files, to read important files, and to analyze this. Both of these packets have functions to load files with a lot of data. Both of these functions. So inside package NP there is, if you use tab after the dot and the name of the package, or at least the nickname I've used, there is NP load text. I'm going to see that, and I can use a file name or a full path name. There is a file here in my computer called wine.csv. Could not perform string to float, so there was a problem. What was the problem with this file? If you open this file here in my computer, it's a CSV file, it's a comma separated value file, you see, and it has a first line with names, with labels, and all the other lines are lines of decimal values. So I have to prepare my function to load this data accordingly. If I go to the documentation, this is the skill I emphasize you to know, numpy load txt. Let's see what the documentation says about this function. You see, you pass a file name. There can be comments. I mean, the text file that I'm going to read can contain hashtags, which will state comments, which will take lines as comments, so not to be read. I can force a delimiter, so I can say if the columns of the file are separated by commas, by dots, dots and commas, or whatever symbol I want. I can use, I can say that it has a header, that I should skip rows. For example, like skip row 0, it means I do not skip any row, all the rows contain data. Skip rows, it means the first rows I'm going to be ignored. I can change the maximum number of rows I'm using, and the class of data I'm using usually is float, a floating point number. And use calls, I mean not all the columns are going to be imported. I will select a few of them to be imported. Okay, so probably the problem here is that the first line is not a line of numbers, it's a line of labels, and I want to read it as labels. So if I do that, I will use the skip rows and parameter, and there's another parameter. It's delimiter. The standard delimiter is known. Okay, my delimiter here is a comma. Now I have read the full file. And this kind of procedure is common when you're reading files. Since it is a function to read CSV files inside Numpy package, it is a function that will produce a Numpy array. as an object, as an external object. So M is a matrix with all the data I want, and this the standard behavior for Numpy package is to read matrices. So therefore, the reason why the first line of labels was not read. So all the numbers are here. I do not have the labels anymore. I must interpret it, all the numbers in this matrix, as rows are a particular kind of information and columns are attributes in this information. In this particular case, in this particular file, wine is a set. Every line is a model, is a wine brand on the supermarket, and every column is a characteristic of this wine: alcohol, malic acid, ash alkalinity, magnesium, and every other interesting things that can be used, that can be measured. And since the matrix is read, numbers for lines and columns can be indexed in the way we have seen before. So this will read line 3rd, column 4, starting from 0, okay? And also all the other indexing options. For example, all the lines from the 1st up to 1 before the 5th, all the columns from the 4th up to 1 before the 7th. So this is a submatrix, okay, a sub-array from that Numpy array. Yeah, and I can use it to do statistics for all kinds. So let us suppose that the first line is the alcohol percentage for every wine. I want to do an average. So NP min. The first column, the alcoholic percentage. So all the lines in the first column, and this is the average, 13% of alcoholic percentage on the wines, and I can take average from all the points. STD, standard deviation, and there are many other variables, many other functions, statistic functions that can be used. But before going to that, I would like to read this file again using the other package pandas. I emphasize that there is another package to read CSV files, text files like this that contains just text separated with a particular symbol shaping a table. That is called the CSV package. But the CSV package is, you could import it here, import CSV for example. It's a very sophisticated package and it's built in order to deal with complex and hierarchical CSV files. So I want to specify a particular template for the CSV file. And that's not our case. Usually we're dealing with scientific data. Our template is very clear. Our template is a table. Okay? So I will be wasting my time using CSV package for this for this kind of application most of the time. I can even use CSV package to build functions like that, like load text. So inside pandas package there is another function. You're going to see that's read. There is read CSV and read Excel and read other formats, read JSON, read HTML, read ATF, several file formats that we're going to see in our classes. But the one I want to use now is read CSV. So read CSV, and I will pass on file name. Okay, and it's read instantly, no mistakes. Okay. Why? Why? Because the delimiter in this function already is standards to comma. And another thing is that this kind of function already reads the labels from the first line and assumes that the labels are in the first line. And the labels are taken as labels to the data structure that this function is reading. This function from the pandas package does not returns a Numpy array. It returns a different kind of object that's called data frame. It's the same name to the structure we use in R, that program and language. You're going to see now that M is a data frame. Okay, type underscore frame, data frame. A data frame is not like a matrix, okay, because it contains names for its rows and optionally names for its columns and optionally names for its rows as well. but it does not possess all the matrix algebra properties that a matrix like a Numpy array has. So it's a different approach. It's more used for statistical data and for empirical sciences as well. So we're going to see that M imitates a lot the behavior from data of data inside the R. I can index a data frame using the names of the columns, using the names of the columns as if they were dictionaries in Python. I haven't shown you in the last class what are Python dictionaries. I'll show you in the near future. But what does that mean? If M is a data frame, any name for its columns can be used to index the data for it. For example, if I use alcohol inside the symbols for a string, you see, the result is a series of numbers contained inside this column for alcohol. And this name was read as a label from the file. Of course, my label names must be both explicit, both must contain the information, and not too long, not too descriptive. Okay, so there was a compromise between having a good name and a name that explains what I want. Of course, you usually have a short name here, and at the end of the file, or in the second line, have a longer description, a longer statement for that. That's an option. So M, table M, if I take, for example, hue, that is again, it's a float, 64-bit float, 178 numbers taken. See, it shows as a series. There are two numbers. It's not just one column of numbers. It's the value and an index. Because when I index a data frame, I take out a series because it contains the row numbers. However, the series can be used much like a Numpy array. If I want the answer to be an explicit Numpy array, I can use this values. You see, dot values from any series or from any data frame will return a Numpy array. So this is the Numpy array of hue values from this file that I have read. And I can, from this point on, use statistics inside Numpy package. So np.min is, of course, the average for this. So you have read files using Numpy and using pandas. With the different pandas, we'll read a data frame, different kind of object. The data frames, they have, just as Numpy arrays, the option that they are also iterable. So for C in M, if I choose print C, you see, he has read the names for each column, the name for each data. When I say to print C, if I say print C point values, it returns just a string. Okay. If I say just C, it's not printing. Okay. So it's the names for every label inside the data frame. There is something called a describe method if you're in doubt of what a data frame contains. Describe, you see, this describe will make a summary statistic on this data frame. So since it contains already names for its columns and information, you will see there are something said here: count, mean, STD, mean, 25%, 50%, 75%, and max. So these are the number of elements, 178 elements. Mean is the average, of course, of every one of these attributes. This is standard deviation for every one of them, the smallest, the largest, and its quartile value. So 25% are up to 12 here in alcohol, 50% are up to 13.05, and 75% 13.67 alcohol percentage. So this is the basic statistics for all the data frame with just one function. It's a quick view on all the information it has. Okay. So the fact is that statistics from empirical point of view are most commonly done with the pandas package. So if you use the pandas package, many statistical functions are already inside of it. You usually will not have to access more sophisticated statistical functions inside Numpy or inside other packages that we're going to study. And today we will stick to the basic functions to start things off. Okay. Well, a data frame, just to note, it can be indexed and accessed in many ways. So if you use square brackets and the name of the column, you have already seen what happens. But I can use a different notation, use the method lock, using the function lock. Okay. Lock will use row and column indexes. So this is the element in line 0, the first element in column taken as ash, as the name of it. Okay, so if I can do indexing, but this indexing is different from the usual Python slicing that we have seen before. When you take the lines as 0, 2 dots 3, I will take all the lines from 0 up to 1 before 3. In this case, when I use the lock method from a data frame m.lock, I will take all of them from 0 to 3. It will not stop at 2 as it's usual in Python. Okay. There is also another name. Another method, that's ilock. It's very similar to lock, only that it uses indexing with numbers. So this 0, 1, 2. You see, this is usual Python indexes from 0 to 2 because it's 1 before 3, and the column is 2, 0, 1, 2. It's ash in this case. I will use not names here. So if I want to work on the data frame using the numbers for the columns as indexes of a matrix, I use the ilock, and it will also use regular Python indexing. Another thing to note is that if when I'm indexing the columns, I have used just one value here and just one value here, but I could pass a list of values, a list of possibilities, and the return will be accordingly different. So if I take ash and magnesium, you see, I've taken as a list, there are square brackets here and commas to separate the elements of a list, so I took 2 columns. But you see, what was printed here is differently formatted. For this is not a series of numbers, since it has 2 columns, is a data frame again. It's a part of the data frame, is also a data frame. I can even attribute to another variable if I want it. Okay, so n will be now, inserting a new cell below, and be now a new data frame. That's a sub-data frame of the original m. And the same is valid when I use numbers. If I take from 2 to 6, I mean this, from 2 to 6, this is an indexing, okay, it returns a list already, so this is a sublist, a submatrix, so in this case a subdata frame. If I pass on a list, it will work because I use indexes. So I can choose, select columns and select lines, of course, as well from the data frame, using their names or using indexes, and it will return another data frame. Okay. Going on, it's very important in this case that you're familiar with how to use this these objects, because they will make your life a lot easier when doing the calculations we want. For now, we are still studying how to use the main object of pandas package and Numpy package. In pandas, there is data frame, there is the main object, and in Numpy, there is the Numpy array that most of the time I also call a matrix, although it's not an exact comparison. So there is, inside every data frame, there is an object, there is an attribute, shape, that presents the size. It has 178 rows and 14 columns. It's the same attribute you would find in a Numpy array. Okay, if I have read this file as a Numpy array, I'll read it again with the name D. And there is D, see? D.shape. It's the same answer. Okay? And I can output the names of columns, m.columns. See, a list of names for all the columns of the data frame. And I can use selections. That's what makes data frame very interesting from analysis point of view, because I can use very smart indexing inside data frame. For example, I have M is a data frame, and imagine I want to select from this data frame all the wines, which are instances in the rows, which have a particular range of values in alcohol percentage. So I could do something like that. I could do M of alcohol, and I will say greater than 14. Greater than 14. What this outcomes a series, okay, a list of values true or false. Remember, this is a logic operator. You will compare all the values in M alcohol with the number 14 and say if it's true or if it's false. When you have a series or a list of values, true or false, as an answer, you can use it as an index to another matrix or as an index to another data frame, as long as it contains the same number of values. So I can use it as an index to the very data frame M. What does that mean? And I will take .lock function in the column alcohol. In the column alcohol. What does that mean? I'm sorry. M.lock. Okay. And then I'll say M of alcohol. Greater than 14. It has worked. You see, this is a logic operator that returns true or false. Whenever I use a series of true or false as an index to another matrix or to another data frame, it will select only when the value is true. So when I use the command lock to index the lines where this is true in the column alcohol, and I can do more sophisticated things. This is the list of values hash whenever alcohol is greater than 14. So I can do arbitrarily complex indexing. Okay. I don't know if there are wines with alcohol greater than 15. No. But let me do something more complex now. I want to select from M, so M lock, whenever alcohol percentage is greater than 13.5 and alcohol percentage is smaller than 14. So I'm choosing a particular range of alcohol values, and I'm choosing a few columns, and I'll create a new data frame for that. For example, magnesium and hue. Magnesium, hue. What have I done of wrong? I'm sorry. I cannot combine more than one condition here because they are series, not numbers. Let me do outside of it. So the range that I want is however, because range is a function in Python. There is alcohol dot values greater than 13.5. You're going to see that air is now true or false, and m alcohol dot values. When I'm using values just because I want to combine true or false of series. If I did otherwise, I will have to take just one logical condition. Values smaller than 14. So this is a range. Oh, it's because the end function I cannot use. I'm sorry. So is okay, I have to use any. So this is the range, and I have another range if I wanted smaller than 14. Call this range 1, this range 2. And then you can see and 2. If I do not say values, the result is similar, but it's not a Python array. It is a series. You see the value and the value in the row number. Okay. Now I can combine this as indexes. One magnesium hue. This would be a new data frame where the indexes are just that. Where the indexes are just the ones larger than 13.5 for the alcohol percentage. And I could do that again. See, a new data frame. And I would index it using the other range now. And you will see G, only the ranges I wanted, with the alcohol percentage between 13.5 and 14. For the values, they are not alcohol percentage. I already excluded as a condition, as a constraint. So any other complicated combination can be done to index part of the data frame. Okay, I can even compare to values. I can say greater than, smaller, equals, any of them. All the data frames, they have some basic statistics functions embedded in it. So I can use now g.mean, you see, and you answer with the average for each, since it's a data frame, for each of the attributes, magnesium and hue. You have means for all the values. And a common thing to do is box plot. It's the first statistics plot that you can have here. and it will give you, it's a box plot with the values. You see magnesium ranges from this area. You could say that if you use describe, remember describe, the mean is 103 and the quartile distances are here and marked in the box plot graph. Okay, so those are very different numbers. So it's the first statistic analysis you can do. You can also run a few tests. We're going to see soon. A very common graph for a diverse analysis is the scatter matrix graph. That will you have a series of statistic variables and you want to compare the tendencies from one to another, several of them. This kind of graph is scatter matrix. It's inside a subpackage of pandas. It's called tools. Import pandas dot tools from import plotting. Okay. And I can give a nickname as well as PL. PL scatter matrix. It's a function. Okay, I have to pass a data frame to use it, and I will pass not just not the whole data frame because it will be huge, but perhaps a few of the columns. Let's say alcohol, ash, magnesium, hue, 4 variables. If there's one mistake, let me see. And from alcohol, I have to, if I want only a part of it. Now it's a, you understood, now it's a data frame because I have index with a list of names, with a list of labels. So I have, if I want to use a list of labels as an index, I have to use another square brackets because I'm passing a list. Okay, or use lock. So pl.scatter matrix. Now this is the scatter matrix. I have analyzed the distribution, the scattering from every variable to every other variable. So hue to alcohol, hue to ash, hue to magnesium, and when it's hue to hue, we use an histogram. Okay, so this is a histogram. When I'm correlating a variable to itself, it's just to draw the histogram, and the other graphs are distributed, so I could easily and graphically see if there is some tendency, some linear or non-linear tendency from one variable to another. If when I increase ash, hue is increased. When I increase magnesium, if alcohol is increased. This all in one, just one window, just one graph, to see if I can, what would I like to analyze from now on. Okay, so I can start doing some diverse statistical analysis. If I were to use all the data matrix, all the data frame, that would be a long time, okay? Because I have 14 measures, right? But while it works, other very similar ways of analyzing statistics in Python and using these packages, or as I said, using Numpy package, and we're going to see in future events more sophisticated packages like scikit-learn that does machine learning analysis with these numbers. Going to see, it's still processing plot. Maybe I was too ambitious when I asked for this plot. Remember, this is a tool for a very initial statistical analysis, right? Because I'm looking if there are correlations between one attribute and the other, graphically speaking. After I identified, because it was graphic, it was even hard to read, right? Because of so many variables. When I see that, I go, oh, I mean, this variable and this variable are related. And let me analyze that with further technique, with further calculations, such as t-test and ANOVA, that we will see in further classes. Well, taking, let me see if a simpler, not all the variables, just G, for example, will be just the two variables, right? Magnesium and hue. They don't appear to have any distribution, they don't appear to have any correlation, okay? Well, I can also use the data frame object to organize my data in more complex ways. I can use it also to write to files again. If I made all the analysis and create a new two, so it's g.2 CSV. I could have a results file if I wanted to separate, for example, a few data and calculate and add a new value. I would write to another file to CSV with results.csv. Well, this is basic use for Python, for packages pandas and Numpy. Load it with, as a matrix, we load text, and read CSV to load as a data frame. Then I presented you what data frame is a structure, is an object that imitates a lot from R language, because it's a table with labels. I can index these labels with numbers or with their names, creating a series of numbers or subdata frames. With the subdata frames inside, I can use functions to do statistics. So I have described that this summary of everything, standard deviation and mean. Box plots are embedded in the data frame object as a very simple graph. I could do a box plot from everything, would be something even hard to read. Okay, there will be many box plots, okay, 14 box plots. And I can have scatter plot just to start a statistical analysis, you looking graphically if there is a correlation between a variable and another. In the next events, we're going to do some more advanced statistics like hypothesis tests and analysis of variance using these two packages here that I have just outlined today. Okay? I hope you have found useful, and let me know in the comment section. Thank you very much.